Hello, everyone. Welcome to the next installation of the Taqueria office hours. Today we have some really interesting demos for you. We're going to show the usage of the Taqueria's contract type generation plugin, which allows you to generate TypeScript types from a Michelson file and then consume those TypeScript types in a DApp, specifically for Taquito, which provides type safety. We're also going to cover the upcoming changes to the config.json file and behavior of environments, which gives first-class access for environments in a much simplified configuration approach, as well as covering new features which allow deployment and interaction with mainnet, and Michelson highlighting, and some other Michelson developer features. So we'll bring on Jimmy here, who's the engineer who developed a lot of the mainnet deployment and actually a lot of the Taquito, Lego, and SmartPipe plugins. So yeah, Jimmy, I'll let you take it away here. We can get going with the demo.
Okay, thanks, Houston. Okay, let me try to share my screen here. Okay, so here's my screen, my terminal, and here's my demo project. So I've already had this a Taqueria project set up. It's just a Taquenet demo, and then now here I am with the demo project, and I'm going to show how to deploy or how to compile a legal contract, which is this one, which I got from the website, and then like show how to compile this along with the storages and the parameters, and then show how to deploy this to mainnet. And here. Okay, so here's a config file, and here's an environment config file. And so what I need to do here is I need to, like in the beginning, when you create a Taqueria project, it only has network name, mainnet, for this file. But in order to deploy to mainnet, you need to have your own wallet, your own key. So what you need to do here is write all this thing. You can name it however you want. I named it as temp user because I'm gonna delete it later. And so what you need to do is replace this and paste your secret key. And you're not supposed to like commit this file because you don't want to expose this secret key. And in the future, we're gonna make it so that probably it would refer to a file that has the credential. That's a safer way to go. And by the way, that's what I'm doing something called in-memory signing. Right, I'm gonna copy the key, but I'm gonna pull this file to a different screen because it's because I'm about to paste a secret. Can't show it to anyone. Okay, here. So I've pasted that. That's good. Let me get to the terminal now. Compile. Okay, it's gonna take this file and it's gonna compile it down to counter.tz, as you can, along with the parameters and storage files here, 12 and etc. Like this is a contract that I'm going to deploy with this initial storage. Okay, and here we go. Sorry, I meant deploy. Going to deploy that contract along with that initial storage. And here I'm going to deploy to production. That's the environment. So like config, as Houston said, we had some environment schema changes. So this is the new environment schema that Rick's going to go over later. But basically, in a new project, we have all these 3 environments set up for you. So when you're doing development, you would be using a sandbox usually. And when you're testing it, if you want to test on a ghostnet, you would be targeting the testing environment. And if you want to deploy to production to mainnet, which is basically production code, and you use the production environment, and that production environment is associated with this file called config.local.production.json. And so when I specify the production as a value of this env flag, I'm saying that I should target the production environment when I'm deploying the counter contract. And the sender would be temp user, which is the user that has the secret key. Okay, let's see. Let's deploy and see. Here's the account. In a few seconds, you'll see new contract being deployed here with initial storage of 12. Gonna take some time because I'm deploying to mainnet. Let's see, still going on. Okay, now it's deployed. This is the address of the newly deployed contract, and it's been deployed to mainnet via this node, which is this is a ECAT hosted node. Okay, and if you search, well, you could, if you search this contract, and you see that it's on the chain now. It's on the mainnet chain, and storage is 12. And let's say you want to interact with that contract. We do a transfer. Don't think I have it in my history, so I'm going to type it myself. Maybe I do have it in the history. No, I don't. I have to type it myself. Transfer, contract. Let's see. I want to target the production environment. We'll send it to be temp user. Let's see. I want parameter. So what would be the parameter? Let's see. So here I'm going back to the contract. Here I want, let's say I want to call the increment entry point. This thing is being compiled to parameter file called counter parameter param1. So counter param counter parameter param1.tz. So this command is going to invoke the entry point counter in the environment, targeting environment, in production environment, coming from temp user, the sender, with this parameter. So this parameter determines which entry point you're calling and with what value. So here I'm saying increment the contract by 100 because that's a counter contract. So here, let's see. And then you'll see, okay, that's the user. Oh, it's already showing. Okay, I think it's done, but I guess it's doing some sort of confirmation. Okay, done. Now successfully incremented the counter contract by 100. I think this is the sender, and this is the contract. Click it. So you can see it's being invoked on its increment entry point. And if you go to storage, it should be 112. And indeed it is. And that concludes the demo.
Awesome. Thanks so much, Jay. I'm really excited
No
to see what our users can do on mainnet now.
worries.
If there's any questions from anyone in the watching, you can submit them via Discord or the YouTube chat or tweet at us, and we'll address them during the live question and answer session. If anybody out there watching is also interested in joining, I will post the link to join the stream as part of the live Q&A, which will commence once we've finished the next few demos. Next up, we're going to bring on Rick Love, who is the engineer who built our contract type generation plugin, as well as a bunch of other cool stuff in the Taqueria internals, and has just recently completed work on the config.json schema refactor and some work on environment. So he's going to demo both generating TypeScript types from Michelson files and how to use them in Taquito, as well as the upcoming backwards compatible changes to our config file. So with that, I'll let you take it away, Rick.
Okay, thank you. So the main thing I want to demonstrate is how the TypeScript contract types are used in basically once you've got your contract compiled, you have generated the types, and how they integrate with Taquito, and how you would use those generated types. So let me share my screen here. Just a second. I believe this is the right thing here. So, yes. So in our if you ever need a reference in our demo in our repo, we do have an example folder that has a lot of different examples under example usage. So I'm just going to look through this since it has kind of a full example of different things you can do with the generated types. So again, I'm focusing on the usage of this. Generating these types is very simple. When you're installing, when you have TAC, you have your contract compiled. All you have to do is TAC generate types, and it'll generate these files for you. So I'm just skipping ahead to what it actually gives you, how to actually use these types in your project, since that's more of where the confusion comes from, I think, when using this project. So once you generate types, it'll spit out into a folder, and your application you can either copy, or with the generate types plugin, you can actually target to a specific folder, and that would maybe be installed under your your DApp. If you have like a React app or something, you might generate those types directly into the React app file directory. So assuming you have that, all you need to do is import your from your generated types. Let me give you a preview of what that would look like here. So this generates, this will look at the compiled contract, the TZ as input, and it generates a type representation for the storage and for all the method endpoints. So as you can see, this is kind of a complicated NFT auction contract that's used as an example. And so it has a complex storage type with big maps, everything from basic fields like a natural number to big maps, which require a little more advanced access. And okay, so that's storage. It shows you all the fields here, and I'll show you how to use this in a second. And then we also have methods and methods objects. Methods object. Methods object is a preferred way to access methods with Taquito because it has a more structured interface versus methods. Methods was the original implementation where everything was a little more flat. Methods object, you'll see the difference in a second. But basically, each of these is an endpoint in the contract that could be called, and it kind of turns it into what you'd expect from JavaScript, just a function call with a promise. And it's a little more complicated when you use it in Taquito. Let's get back to that. So the trick here is whenever you originate a contract or whenever you access a contract with Taquito, the at parameter, for example, deployed contract, you'll use at and give it your contract address in your DApp. And the important thing is this at in Taquito has a generic, and you need to provide that the contract or test wallet. You have a wallet or a contract. In most cases, it's actually the wallet version of this in Taquito in the DApp. And when you have that, it gives you a contract object that has a typed methods and a typed storage. So let me skip down to methods object since this is the preferred way to do things. So methods object is now completely typed. It has a for every endpoint, it has the parameters that are expected. So anything, as you can tell, like bid, for example, requires a single natural number. Configure, which is a little more complicated, has a kind of an advanced, parameters here. And the entire object is typed. And in both, you can't, for example, let me learn how to type. If I put an extra parameter here, it's going to warn in that case. And so that will help prevent typos. It'll help prevent providing parameters that are stale or maybe your contract changed. And on the other hand, if you have a missing parameter, it will also warn you that this is an invalid object. It doesn't have everything required. So everything about the parameter should be required by TypeScript, and this will help you both verify you're using Taquito correctly and using your contract correctly, providing everything. Okay, so that's the methods object. It's hard to gauge how fast I can go without interaction, but hopefully, if you have any questions, we can discuss that later. All right, so that's one. So that's the main way you would call or call endpoints, and this would give you back just standard Taquito interactions where you'll get back from this an object which you would then wait for the results or confirmations. This is a minimal example, so I don't really have all that typed out, but you would call send on it, and then you would wait for the confirmations to get, you normally in a DApp, 3 confirmations, whatever. And basically that just verifies that your contract has been updated. Of course, to get the data from the contract, you need to use storage. So let me go down to an example of how to get storage values. Okay, well, actually, this is a good example. Let me, before going to accessing storage, let me go ahead and show you how would you originate a contract. So if you're originating, you always need to provide a storage value. Now, depending on how you deploy your contract, whether you're doing this in the context of CLI tool or if you're doing it somewhere else, you might have your originate in the browser, you might have it in your CLI. But if you're writing a script in the CLI, then it's still the same way. You use Taquito. You provide in the originate call for Taquito, you provide the type for the wallet or the contract, depending on your context. And at that point, the storage has to be completely typed. And so same example as a parameter, everything has to be provided if it's for any required state. If you don't put anything, I'm just going to blank out this. It's going to error, give you TypeScript error telling you that you have a missing parameter. Same thing as you'd expect anywhere else. If you have a typo, again, it's going to, valid type. It's going to give you an error there also. Okay, so one thing that I'll get to in a second is this TAS helper object, but I'll do that in a second after we look at how to access storage. Okay, so this is a good example. I made in this example, I made a helper function to get a specific value from storage. And so you get the contract, again, you type the contract, so you have to have access to it using the either at or originate, providing the contract type. Once you have that, to get storage, you'd call .storage await.promise, and then you have all of your storage parameters. So I could access any of those. If it's in the example here, auctions is a big map object, which you have to access one by key and wait for the result, which is why this was wrapped in a kind of a helper function to make this easier. Okay, so in this example, I get the auctions big map, and then I have to call get, providing it the ID, and I will get back the auction after waiting that promise. And so again, when I get the auction back, everything about it is typed. So if you look down to where this is used, all the values that were part of that auction object are automatically known because it's part of the storage, and I can just work with it like any other JavaScript object at this point. All right, so I believe that's a decent example of how I would recommend kind of structuring access to storage, make helper functions, which would be a lot easier to work with your dApp, but you're getting the storage, you're getting your objects. If you have a big map, then you're providing the IDs and getting those individual values out. Okay, so I guess the next question would be, why above here? Okay, so what is the purpose of this TAS object? Okay, so this kind of it's taquito as kind of play on words. It's a tool. It's included whenever you compile your types. This is automatically generated, but it makes it basically provides strict type safety when you're working with contracts. For example, if you have a natural number, you want to make sure that that's not a JavaScript like a floating number or some invalid number. And instead of waiting for a runtime error, whenever you try to call that at runtime, the TAS will verify that you're actually providing it. It helps you verify that you are intending to provide a natural number. So for every contract type that's specific in the contract language, you have a TAS dot version that will help you, convert strings to that type, convert numbers to that type, verifying that you're intending to provide the correct type. Good example would be the difference between mutez and tes. Obviously, that would be a big mistake if you mix those up. So in all these cases, this is basically allowing you to cast to the specific type that the contract expects, and when you get that value out from storage, it's still also typed. So, for example, if you wanted to use this amount, in this example, I'm getting the current bid value from mutez, and I'm adding, 1,000 to that. And so it has some helper functions to the TAS utility to do some math. Since you can't just take a specific mutez type and use JavaScript adding to do that, you do have helper methods to kind of work through that. system. It's not as straightforward as just putting, number plus 1,000, but this provides the strictness that we should expect when we're working with the contracts, so we don't have some kind of bug that's rather important. Of course, I would expect all of this code in your DApp, should be done in. I'd recommend isolating that kind of contract access layer in its own files, so it's not spread throughout your DApp. You have a little more utility when you're using that in other places in your UI. Okay, so I hope that is a good overview of how this works at runtime, or how this works when you're coding as far as using this. I expect there's probably a lot of questions, but we'll try to add references to examples. And I think this file is actually very good, a full use case of all the possible things you can do with the contract generated code, or the contract types generator, and what it'll do for you. I can't imagine using Taqueria without this, since obviously calling methods and other things, providing the storage when you originate, all those things are quite difficult unless you're very specific and very careful. So all this types just makes it 100 times easier to work with. All right, I don't know if you wanted to, Houston, if you wanted to pause for a second as I get ready for the next transition.
Yeah, we can just take a moment here. We'll do another shout out to anybody that might be watching the stream. If you would like to join, our live question and answer session will come up in the next couple demos. Please either submit your questions via Discord or the YouTube live chat. You can also tweet at us or message us on the LinkedIn live chat as well. And I will put the link to join as a guest up on screen shortly here. And Rick, up next, he's going to show the upcoming changes to config JSON, essentially a schema refactor to make things a lot simpler. It also changes the behavior of environments slightly. This change is fully backwards compatible, so we shouldn't have any effects on end users with existing projects, but this will serve to give a good idea of what's coming down the pipe and some of the improvements behind the scenes.
So this next change is an update to the config JSON file, which you find under the tac folder. So I have an example here of what it was and what it is now, after this next release. And basically, we simplified the environment's structure from config in the config file, which it was a little more flexible before, but it required a lot more kind of thinking through things. So we try to simplify that as much as possible, and it should be much more straightforward now. So I'm going to first look at the old version of the config JSON and demonstrate and focus on what the differences are. So in config JSON, you have, after you set everything up, you'll have an environment object. And this environment object has multiple keys for a key for each environment. And the complexity of this old model came from having for each environment name, you had a networks and sandboxes, and so it was a many-to-many relationship where you have the sandbox name, for example, and you have to then look at the network and sandbox objects in this config JSON to find that. And then all of these parameters were part of that environment. And so the initial design was to keep it very flexible, where you could reuse networks and sandboxes. But we identified that this complexity was not really needed, and we in the next version, the updated version of config, you'll see that it's simplified all that. Okay, so going over to the new version. So now the networks and sandbox objects are gone. and all of the properties that were a part of those have been flattened into this new environments object. So the environments object has a list of each environment. That's not changed that much, but you'll see that now it's quite simple. It just has the properties of that environment in a very flat way. There's not any references to another object in this config file. And for example, each environment, relatively straightforward. You have a sandbox, which is a using our Flex Testa plugin. So the type comes from the plugin name or an alias of it. And so for this sandbox, it simply has a label and an optional protocol. And that's it. So this is a lot easier to understand. You can come in and change these labels or properties very easily. And for as another example, this testing environment, we use simple, but basically that just means that it's an RPC. It's an external URL that you're using as an RPC, and the label doesn't really mean anything. That's just for your own reference and for use in the CLI. And that's just an RPC URL like you would use with mainnet or any testnet. Again, protocol's unnecessary there, but that's just kind of a complete example of how the change is different. Okay, so that's the simplification here. We also have the environment default, which is going to be used by default in the CLI tools. So if you did want to change your default environment, all you have to do is change that string to point to the other environment name, and that would be used for when you have a default environment in your CLI in the TAC tools. Okay, so one other change I wanted to go over is that another issue we had with the old version of config is there were secrets in here that were sensitive, especially if you're dealing with mainnet. So, for example, you might have a private or a secret key for a wallet for testing, and obviously you don't want a secret key or private key to be leaked or seed phrase to be leaked to your repo, and that should be something that is sensitive. It shouldn't be added to that. So we now have split the environment into multiple pieces. You have the config JSON, which are the environments. You have the shared configuration values here. Sorry. These are the same for all developers who are working on this project. It's not sensitive. These can be shared, and in most of the TAC tools, the TAC plugins, if you the things that are missing from here would be automatically generated for developer. And so the idea of the config.local file is that for each environment, you would have a config.local.environmentname.json, and that would have things that are specific to the developer. And so these are fields that only the developer cares about. And for example, this RPC URL for my sandbox. If I have multiple sandboxes in Flex Testa, I could have a different port number that's local to my system only, which is great when I'm working with multiple projects because we might have I might have a port conflict and I need to override that for my environment. Other things are local state. For example, this is storing one of the tools, the TAC plugins is using a storage value here. And so it can use this, but it's local state that's specific to me as a developer. So this won't be saved in the config.json where it conflicts with another developer and his local state on his sandbox. So any fields that are not specific to that are not shared and really part of the config or kind of the project's shared state will be saved in this local config so that it can be automatically generated if it's not there, and it will be specific to the local developer, and so there's not conflicts when testing. Works the same for other things. For this is a good example. We have a testing environment. It might be deployed to GhostNet. I have this Hello Tacos contract address, and it's deployed to testnet for my testing, but that's not an address. Maybe part of that contract is that the person who deployed it is the owner of the contract as the admin. They have access to all of admin endpoints, which are not going to be the same for another developer who was not the address who was not the owner of that contract. And so this allows each developer on the team to deploy their own version of the contract to testnet, to GhostNet in this case, and they can each have their own address. So when they test that, it won't conflict who's the admin, other things. So I hope that basically that explains why we're doing and what changes you can expect to see if you do go into config.json. Another thing to kind of talk about some of the other improvements for you. The old config JSON, the way we're serializing it, sometimes the order of properties could change, and whenever you went to save this in your repo, you would see diff changes just because something moved around. And so this the updated config JSON has a specific order for all of the fields, and it should be consistent. So if you, for example, add a plugin, it's always going to be at the bottom of this file, and that change is going to be in the same place. It's not going to move this plugin's object from the top of the file to the bottom of the file or anywhere else, which could have happened before. So your diff changes whenever you're working on updating your code should be very clear and easy to understand without unintentional differences showing up. So yeah, I think this is helpful for all of us as developers and using Taqueria, and should make things more consistent. As this update also allows us to begin adding more advanced features on top of this, which we can talk about later. Let me think. There was one other thing I wanted to mention. Oh yes, basically all of this is automatic. This config, the new updates to Taqueria will be able to read the old version, and it will automatically update it to this new version. It should be seamless. It should not cause any confusion, and everything that you currently have in config should work. That's always the hope. So it should automatically, for example, in the old version, it had these references to the environments. All these fields will be added to the correct environment and made into this flat list of fields. So there should not be anything you need to do unless you have a very custom config JSON, and in that case, we can help advise on what to do. But ideally, in most cases, it should be an invisible update. And when next time you open config JSON, you'll see this new structure, and it should be easier to understand. So I think that's good for me. Hopefully I didn't go too long. I'm not hearing you, Houston.
How about now?
Yeah, that's great. Sorry.
Yeah, dropped out for a second there. I was just saying thanks for the demos. I know there's been lots of questions on the proper way to use contract type generation, specifically consuming it with Keto. and the TAS object is quite helpful, but something that was a bit of a mystery to users. So really appreciate you jumping on and sharing that. The config JSON schema updates Rich covered will be released in the next version of Taqueria, which 0.2060, which should be out this week. So all users watching this can keep an eye out for that and understand what changes are coming down the pipeline. Just going to put Ali on here. Ali, are you still interested in doing the demo for the syntax highlighting?
Yeah. Actually, it's going to be a very short demo. So, yeah.
Awesome. I'll turn it over to you here.
Yeah, thank you very much. We are adding syntax highlighting and other language service features of Michelson to the VS Code extension. So for the moment, some syntax highlighting has been implemented. It's going to be more complete so that more information is available when you in the context of each of the language elements. But what we have is currently also interesting. As you can see, important elements of the language are color coded now. So you have you can identify these top level primitive applications, and these applications that are used for these primitives that are used to build types and the type annotations. You see all are different colors, and they specialize characters, also the commands and number or string literals. So if you open any Michelson file with extension .tz, this and you have the VS Code extension, the Taqueria VS Code extension installed, this syntax highlighting is going to be applied automatically, and as the scopes are also implemented properly. So if you have some features in VS Code enabled, like this sticky scroll, you will be able to use that. So for instance, you see as I scroll, the top parts of each scope stays sticky to the top, and it works well with most of the configurations of VS Code that we have tested. So it's going to be a nice feature to have if you are going to read or work with the Michelson. And for the moment, it's that's it. Later, we will be adding more and more features to the context menu and information that you can see in pop-up for each element of the language, and we will be differentiating between more of the different kinds of things that the language, the Michelson language provides. Yeah, that's it for the moment for me. Yeah.
Awesome. Thanks, Ali. Really useful features there. I know there's some users who do actually write their contracts in Michelson, and anybody else trying to get a handle on how Michelson works, this makes it a lot easier. So thanks for the demos, everybody. We'll move on to the live Q&A session here. We have Maxime who's joined. He's a power user of Taqueria and has provided lots of interesting feedback on feature requests. So I know you've got a couple questions, so we'll let you take it away.
Hi, thank you for having me. Introducing me as a power user, good thing. Yeah, I have a few questions to probably Jimmy and Rick. So first question, you introduced the new secret config. I understand that you have to add that manually to the git ignore, because obviously you don't want to have this pushed to a repo. Is this something that you thought about adding directly in tacinit, so that tacinit generates the git ignore with the new files?
Oh yeah, I'll probably do that like today. Yeah.
Perfect. It's just so we don't forget, basically, and
For sure, yes.
especially
You
for-
don't want to forget that.
you don't
Yeah.
want to, indeed.
We'll make sure you don't
Um,
forget that.
Thank you. Thank you.
Yeah.
And the other question related to that was that I wanted to modify options to flex test that to the sandbox. For example, the block time. I think the default is 30 seconds, and one might want to go down to 5 seconds. Would there be a way to add such optional arguments to the config files?
Yeah, that's actually a feature that's going to be coming out in the next version of Taqueria. We've introduced for the next version 2 baking options. One is the ability to enable or disable baking, and we've added a task called tac bake to manually bake a block. The other one is the ability to specify a block time. We also, in the future, we have plans to build a system where it's going to be called bake on demand, where essentially nothing gets baked until an injection is off, or operation is injected to the chain, and then it will bake a block then and only then. So every subsequent block will actually have an operation of interest to the developer. I could share my screen here and give you a
Maybe
quick
just a question on this.
overview.
Will there be a minimum time between 2 bakes?
That I'm not sure yet. I think that's still up for discussion. So I'll just share my screen here quickly. We've added in the new config JSON schema, it's a little bit bigger, under your sandbox configuration, there's going to be a new property called annotations. And essentially it has 2 separate properties. One is baking, which could be, it's a Boolean, it can be disabled or enabled. The other one is block time. So if baking is disabled here, you will actually have to manually bake each block, and you can do this by running tac bake local. And you'll see it will bake a block, and then the next operation you inject, you would have to bake afterwards. I'll stop the sandbox quickly here and show you how the block time works as well. So if we enable baking, this is block time in seconds. So I know the default was 30 seconds, but we could just go with a block time of 3. And then start up the sandbox, and that will override the default block time to whatever is specified by the user. So these are both features that are coming out in Taqueria 0.26.0, and hopefully you'll see that by the end of this week, but early next week at the latest. So that's coming down the pipeline. As you can see, it's very clean and easy to configure this with the new config
great.
JSON schema refactor.
Thank you.
Awesome. And I think you maybe had a question about for Rick about the type
Yes.
generation.
So in the type generations, we talked about the method and the method objects. Is there something for the views too? We can't hear
Oh,
you.
Rick, we can't hear you.
No.
Yeah. So
No.
there isn't currently, but I think that yeah, I think that would be easy to add that. So yeah, I think that would be a good feature to extend.
Yeah, over the next few months, we do have plans to add first-class support for views, both on-chain and off-chain views. So if you have suggestions, please feel free to share them with the team. We're always looking for input on what our users are needing, and we'll keep you up to date with those features as we roll them out.
Yeah, so I was a little bit playing around with views and also events. This would also be interesting to have some built-in features for handling all the events. I know this is something that came recently in Tezos, or well, recently, that's a few months. But this is something that would be very, very interesting to have too. Currently, we have to handle everything manually. If we want to listen to events or yes, I believe so. Or if we want to check the past events, so having things built in, I think, would be interesting. And types too for events.
Yeah, and any contracts you have are always helpful. If you have like specific use cases, we can make sure to test those. So yeah, anything you could share to help demonstrate some of those use cases would be helpful.
I will contact you.
Awesome. Was there any other questions, Maxime? It doesn't look like we've got anything
I
in the
think
chat.
that's all from my side.
Awesome. Well,
Thank
really
you.
appreciate you joining and contributing to the discussion. Thanks for joining Rick, Jimmy, and Ali and providing these great demos. We're almost at time here, so we'll wrap it up. And any further questions can be submitted to the Taqueria Discord or reach out to us on the Tezosdev Taqueria channel. There'll be a replay of this available on YouTube as well as Twitter and LinkedIn as well. So thanks again to all the guests. And we look forward to seeing you in 2 weeks' time.